Hello everyone. So let me share my screen and I guess we can start. So Kubernetes in minutes, provisioning and configuring DigitalOcean managed Kubernetes. So first of all, let me run something because creating stuff takes time. So I will start. Oh, I'm in the wrong folder. A demo curse. I need to delete something. Terraform. No, it should be good. Okay, then I just need to go inside Terraform folder and run Terraform apply. So while the stuff is creating, so who is this guy? My name is Grigory, but you can call me Greg. I'm a father of Shiba Inu and two reckless boys. I'm a DevOps team lead at Navitech. We provide DevOps services for customers in Israel and European Union. So first of all, why Kubernetes? Well, for me, it's not really a question, but I should answer it. So because it's a standard a while ago, there are no doubts it will be adopted by more and more companies. You have a lot of things done for it and with it in mind. So it's a nice thing to learn if you haven't tried. Why DigitalOcean? First, you can have clusters up in minutes. I will be showing it during this demo. You can have auto-scaling both pods and nodes, easy to configure it and literally few clicks somewhere or few lines of code. You have automated minor version upgrades, one-click apps from the marketplace, super nice thing. I will be showing it during the demo, and traffic pooling, like free amount of traffic is stacked and shared between the nodes in the pool. Let's talk a little bit about how managed Kubernetes in DigitalOcean looks like in a schematic way. So if we go from left to right, like you have load balancer as a service, which is a pretty much industry standard. You have worker node pools. You can have multiple pools per cluster with different kinds of droplets in sizes and amounts, with or without auto-scaling enabled. In terms of storage, you have multiple options. You can have volumes attached directly to a storage one-to-one. You can create several droplets or one droplet and have a network storage, which will be mounted by the worker nodes in your cluster. Or you can use spaces, which is object storage, S3 compatible object storage, so you can easily embed it into your system. In regards to the master nodes, so by default, the control plane is free, but you have only single master node. If you want to have high availability, it's a bit extra, or you just run four plus worker nodes in your cluster and it will be enabled by default. About pricing, so and the nodes and droplets in general. So we will be using, for the sake of this demo, basic droplets, regular, not premium. They are suitable for things we're going to do here. They have shared CPU. If we're talking about real production loads, I would recommend using something from other kinds like general core purpose or CPU memory storage optimized, depending on your needs, because they have dedicated CPU and they are like production proof. Next thing, let's talk a little bit about tools we're going to use today. It's a short and simple list. Terraform is a go-to when it comes to infrastructure as code in most of the cases. DigitalOcean control and kube control are tools like together with Helm. Let's talk about DigitalOcean control separately right now. So DigitalOcean control is a CLI tool that allows you to manage, list, and control the stuff you have in DigitalOcean, and we will be using it today to list the clusters, to install something into them. And kube control and Helm, well, it's again a standard when it comes to Kubernetes and installing packages into it. A little bit about preparations I've made. So we have to generate API key. You can do it by yourself by opening this URL, making a couple of clicks. So the API key should be stored securely, and I recommend having it short-living, like 30 days or whatever, because long-living keys are a threat. Let's briefly talk about definition of done. So what will be a success of this demo? So we will have DigitalOcean Kubernetes cluster running with multiple nodes and auto-scaling enabled, both for pods and for nodes. The demo application will be deployed and reachable from the internet over HTTPS with a valid certificate. What do I mean? So we will be installing a small application into a cluster. It will have an ingress. That ingress will cause creation of a load balancer. It will, we will create a DNS record, which will be pointing to that load balancer by saying we actually mean external DNS. We're not going to do it by hand. And also the cert manager will create a valid Let's Encrypt certificate for that domain and attach it to the ingress. And we will be doing as less manual actions as possible, but I will be trying to show diverse ways of interacting with DigitalOcean Kubernetes. Okay, that's good. Enough slides. Hands on time. Oh, okay, it's not too bad. Looks like I forgot to export the token, which is not too bad, but may take more time than I was anticipating. 5 more minutes, but we will be talking about different things during that then. So let's talk about the Terraform code. It's pretty much simple. So what we do here, we're incorporating the module with like the provider of a DigitalOcean. We are generating a random ID and using it for a cluster name. Then we're doing super simple stuff. We're taking the inputs of the model and populating them. We're giving the cluster a name. We're specifying a region, a version, turning on the updates, enabling the high availability, which I was mentioned for the control plane. We're telling that the node pool configurations are like the name, enabling auto scaling for it, specifying the size, which is kind of worker nodes type, like droplet size, and specifying the minimum and maximum amounts of nodes in the cluster. All of that we're providing here from the Terraform TFR. So we specified the version of the cluster, the count of the workers, the minimum and maximum, and we are specifying the type with all of that. So next thing is that let's talk a little bit about networking. So here we have a domain dedicated for this demo. So as you can see, we don't have any records except DNS records here. So when we will install, when the cluster will be created and we will install some software into it, the records will be created here, which will be pointing to the load balancer, and some records will be created by the cert manager to validate and create the certificate. So if we go here to Kubernetes tab, and open this, this is the cluster which being created for us. Here in the Insights tab, a bit later, right now we don't have any like real CPU usage or whatever, we will be able to see a brief metrics of our cluster. In the Marketplace tab, here are listed the one-click apps I was mentioning. So how it works. DigitalOcean provides you ability to install some well-known Helm charts to your cluster without running Helm or anything like on your terminal or whatever. You can just click install, wait a little bit, and you will have software there. A bit about what do we have in this repository. Oh, by the way, you can access like this is a public repository. It's in the Navitech organization. So you can open it, you can check it out, you can try it by yourself. I encourage you to do that and ask questions later if you will have any. So what we're going to install or configure from this Helm folder in the repository. So first of all, we're going to install the Helm chart of external DNS. So in this README, it briefly explains what we're going to do. It will be, we will need to save up. I did this part by myself already, but it will be helpful for you when you will be trying to do it. So what we will need to do is to, we're going to add a Bitnami repository, and then we are going to install the external DNS into cluster. The external DNS is a tool which is watching for these services like Ingress. And if it finds a domain name which is listed like in this values, I'm listing only one domain, but anyway, which is whitelisted for this service, it will go to your DNS and create records for it. In order to allow that, we need to provide external DNS credentials to access the API of DigitalOcean DNS. So we are going to create a secret. We have here a secret template. It's a super simple thing. Like it has, like, you see 5 lines, like 7 lines, you know. It has name, in which namespace it will be created, and it will be having the DigitalOcean token I generated before this demo saved in this key inside of a secret. So what will happen? Well, let's peek. Okay, cluster will be ready soon. So after installing this, we're going to install, not really install, Cert Manager will be installed by the one-click apps, but we will again create a secret for Cert Manager to manage DNS again. And we will create a cluster issuer, a tool, a manifest. This manifest will allow us to generate certificates for our ingress of the application. And the last thing we're going to install into that cluster is a demo application. It's a super simple app, nothing interesting. I did change the default values of the charts. Don't do this at home. It's only for the sake of this demo. So what we're going to have, we're going to create a deployment and ingress. So ingress will have annotations that it will have ingress class Nginx, it will have TLS ACMA enabled, and the cluster issuer will be Let's Encrypt prod, the one I've been mentioning here. So Let's Encrypt prod. And it will have a domain name of demo domain docs.demo.navitech.io. Next thing I want to explain is that we're going to configure resources, limits, and requests for this application. Okay, the cluster is there. I will quickly finish this explanation. I will install stuff here. So we're going to configure those limits. Those limits are only for the sake of this demo, just to make the autoscaler kick in as soon as possible. The very same reason we have CPU utilization for autoscaling for 10%. So autoscaler will kick in as soon as possible. So what do we need to do now? We will go here to the web interface, and we're going to install the Nginx ingress with this couple of clicks. Very same thing we're going to do with Kubernetes metrics server. We need it for autoscaling. We will install Kubernetes metrics monitoring stack just because we can. And next thing we're going to do, okay, so just to save time, I will be copy pasting some commands. So with the DigitalOcean Kubernetes cluster list, we're going to get the list of the clusters. Then we need to configure our kube control tool. So this command is saving a kube control config. So now we can do this and list the nodes we have. Now, let's run it once again here. So, and this command too. So what I'm going to show you now is that you can install one-click apps from the console instead of web interface. So you can run this command. Oh, sorry. I think yes, I placed it in the wrong. Yes, so if we go back here, oh, actually you can see it here. So it's installing Cert Manager right now. So what we need to do, we're going to do all the exercises I mentioned while the cluster was created. So we are going to install external DNS by just copy pasting those commands. So you can reproduce it. So we have installed the external DNS. We created a secret for it so it can manage the domain records. Now we have created a secret for the Cert Manager. We have created the cluster issue for it. Now we're going to install the demo application to the cluster. Okay. Let's take a look what's happening in the cluster. So we have metrics server installed. We have Ingress there. We have Cert Manager. We have external DNS, and we have our demo application created in the cluster. It's good enough to start doing something there. So what we need to do now is we need to check if we have our ingress. We have it. Now we can check if if the certificate is ready. It's not ready yet. Let's describe it and see what's going on. Okay. The certificate is being issued. So meanwhile, if we get pods, we will see that we have only one pod here. And our goal is to have as many to see if auto-scaling will work. So let's watch the count of the pods here. Not really count the list. And run Apache benchmark. Oh, it's a wrong tab. Okay, not a big deal. So let's get pods here. And run Apache benchmark here. So what it's going to do, it's going to put pressure on the cluster. Yeah, by the way, you can see we are accessing the application via the HTTPS with valid certificate. It says hello from Israeli Cloud 2022 demo. And we are putting pressure on a cluster with Apache benchmark, which causing the creation of new containers. So we have 2 pods already. Next thing is we want to see if the cluster will auto scale in terms of the nodes. So if we get pods without watch, we'll see 3 pods at least, right? Okay, so we already have pending pods, which mean that the amount of nodes should be changing soon. We only have 2 nodes as it was in the beginning. Let's wait a bit. And meanwhile, let me show something else. So you have this, oh, it's failed. Okay, let's trigger it too. So let me show you something else. So you have these just out of the box. It's a dashboard to view the status of your cluster in the web browser. Why this is red? Because we have pending pods for our application. So if you go here, it will be saying that you don't have nodes available and why 2 of them have insufficient memory. Remember that 4 gigabytes limit I was setting just for this. So you can list all the replica sets, cron jobs, like this is the view of your cluster status in the browser. And it's great, like you can view it from mobile while you're commuting, and like it allows you to debug stuff like at least on the top level instantly without anything complex. Like you don't need a computer to do stuff. A mobile phone is fine. And we have to wait a little bit more for autoscaler to kick in. It should be soon. So if we go to insights, so I was saying that we will see some metrics here. So here we go. We can see that we have CPU, load average, memory, and disk usage metrics, and bandwidth, of course. And if we go to networking, you remember I was showing you the empty DNS records, like not empty, I was showing you the 3 DNS records in that zone. So now we have a record, which is pointing to the load balancer, and we have a TXT record, which indicates that this A record is managed by the external DNS. Okay. Okay, we have a new node. Yeah, we have 3rd node in the cluster. So I guess we did everything I was going to do. It's questions time. Oh. How do I see if we have any questions? Yes, we will have a link for the repo for sure. Oh, by the way, I have some slides after the questions. First of all, if you have any questions about this demo or materials in the repository, write an email to devops@navitech.io. In this presentation, you have links to documentation on how to install Cert Manager in DigitalOcean, external DNS in DigitalOcean, link to the documentation of the Terraform provider, the detailed manual from DigitalOcean, like to how to build your Kubernetes cluster for like production ready stuff. Because here we have almost everything, but I'm not showing for the sake of time, not showing how to gather logs, some metrics related stuff, some security related stuff. So yeah, I guess that's everything in regards to my slides. So let's talk about questions.